Okay, so we're looking at iGCSE introductory topics. So it's 4B, energy transfers part 1. So basically, we're looking at the energy stores. You've got to learn all the stores. So they're like little pots where the energy is going. So we're looking at chemical, kinetic, gravitational. So that's where you are in a gravitational field, higher up, lower down, elastic in a spring or stretched elastic band. Thermal, so when an object's warm. Magnetic, when we separate magnets, they attract or repel. Electrostatic, so in separated electric charges that are attracting or repelling. And nuclear, so when we have a nuclear decay, radioactive decay, so that's alpha, beta, gamma, or neutron radiation, so streams of neutrons that have come from, say, fission, or potentially atoms that are fusing. So when the atom splits or atoms fuse, particularly in the sun, they would be fusion. Fission would be a nuclear reactor. We can call that nuclear. Now, there are always transfer mechanisms, so we can go from one store to another. So devices such as like lamps and heaters may be involved in processes such as burning, combustion, but the energy can be transferred mechanically when we move through a distance, a force and a distance, anything that moves. Electrically, when the charge moves through a potential difference, so in a wire, by radiation. So if it's in the form of light, microwaves and sound, we all just call that radiation. And by heating, because of a temperature difference, so when things heat up. Now, we tend to show these sort of ideas by using a box for what it is. So my muscles could be picking something up. So that's chemical store. On the arrow is the transfer, like mechanical and thermal. And then that could go into motion and height. You're lifting an object, so it could go into a kinetic or GP store. So the stores tend to be underneath the boxes of what it is, and the transfers are on the arrows. Try and stick to that format. You get marks for it. Then we've got efficiency, so that's how much energy output over your total energy input, or a percentage efficiency. We take the same thing and multiply it by 100%. It's just like a test score, and I could do that for power as well. So think about a test score. If you got 50 out of 100 in a test, it would be 50 divided by 100, which is an efficiency of 0.5 or 50%. Conservation of energy, we can draw Sankey diagrams that have got a scale for the energy that goes in. So in this case, electrical energy goes in, 9 joules, and then coming out of it, radiation light, 0.8 joules, and thermal, 8.2 joules, which is this thickness here. So it's kind of a scale. Now we call it electrical energy, but it's not a store. It's the mechanism of electrical going in. Now, I would say these are a little bit weird. I don't always think some of the examples like this are very good, but the exam boards are tidying up how they're presenting it. So the key is to look for stores versus mechanisms. So there you go. That's energy transfers part 1.